Hey everyone, it's been a while, huh? I know, it's been too long since my last video. For those of you who don't know me, I am Amin Charot, your friendly neighborhood cloud consultant. And for those who do know me, well, yeah, I've been a bit MIA, right? So where have I been? Honestly, I get caught up in some other hobbies. Let's just say my PlayStation and my Netflix accounts have seen a little too much action lately.
I don't take meetings, I set them. And my respect isn't demanded, it's earned.
That's only two things. What's C?
C is for people who show me they know A and B.
Life is this. I like this.
المغاربة يتواجدون أمام معسكر البحارة. يمشي بالكرة، الهربة ممتازة جدا، فرصة التعادل، كرة مغربية.
But don't worry, I have not completely disappeared. While I have not been making videos, I have still been keeping busy and writing blogs over Medium. So if you missed me, you may have got some of my thoughts there, right? But today, I am excited to be back with something really cool. We are diving into an advanced Retrieval-Augmented Generation. Okay, we will talk about what RAG is, how the advanced RAG takes it up a notch, and even get into some cool tools like LangGraph. And I have a fun demo for you lined up, so stay tuned to see some real magic happens. Alright, enough with the small talks, let's jump in.
Alright, let's kick things off by talking about RAG, or Retrieval Augmented Generation. Sounds fancy, right? But don't worry, it's actually pretty straightforward and super useful. So, RAG is all about helping our beloved AI models when they hit a roadblock. Picture this, you ask a model for the latest research on, I don't know, quantum computing or something. But no, the model does not have that information stored in its brain because it's been a while since it was trained. Instead of giving you an I don't know answer or worse, making something up, RAG steps in to save the day. It retrieves real time, relevant information from external sources like databases or the internet and use it to give you a much better answer. Think of it like your model suddenly turning into a librarian. If it does not know something, it just goes and fetches the latest book or article for you, and voila! Now it's ready to generate a more accurate, up to date answer or response. Why does this matter? Well, AI is great, but it's not all knowing. Combining generation with real world data retrieval means the model does not just rely on what it already knows. It's like giving it a cheat sheet to ace the test. So you get relevant, accurate, and fresh answers. All right, let's break down how retrieval augmented generation works using this diagram. First, we start with a collection of documents. This could be anything from research papers to articles or structured data. The key here is that these documents are filled with information that the AI can later retrieve. These documents are uploaded into what we call a vector database. Now, a vector database is where the magic begins. It does not store the documents as plain text, but it converts them into vector representations, allowing the AI to search and retrieve relevant information. Next, a user comes along and asks a question or makes a query. This is the point where our language model is asked to provide an answer. Before the model even attempts to generate an answer, it queries the vector database for any documents that might have relevant information. Think of it like the model saying, let me check first my references, all right? Um, Once the relevant documents are retrieved, they incorporated into the prompt that the model receives. This prompt combines both the question and the information retrieved from the database. Now, with the prompt that include real-time data, the language model or LLM can generate a response. Since the model is now working with up-to-date information, its response will be more accurate and relevant. Finally, the model produces its final response, which integrates the retrieved knowledge with its own generative abilities. So in a nutshell, RAG enhances the AI's ability to answer complex questions by first searching for the most relevant external information, combining that with its generative capabilities, and then delivering a much more accurate and contextually rich response. Okay, so by now you are probably thinking RAG sounds pretty awesome. And yeah, you're right. But like any superhero, RAG has its weaknesses. Sometimes the information it retrieves might be incomplete, outdated, or just not quite right. And let's be honest, none of us want AI to confidently give us a wrong answer. So what's the fix? Well, onto CRAG. That's Corrective Retrieval-Augmented Generation. Think of it like a RAG with a built-in spell checker and fact checker. It corrects mistakes or low confidence response by going through an extra loop. If something seems off, it will fetch more info or adjust the answer, making sure you get the most accurate response possible. It's like giving your AI a second chance to double check itself before telling you what it knows. So next up, let's break down exactly how CRAG works. Just like RAG, the process begins with a query from the user, and the model searches for relevant documents in a vector database. This database holds information from external sources, and the model pulls the closest matches. The model retrieves these documents and adds them to the context of the prompt. So far, it's similar to the regular RAG process. The documents are used as references to help answer the user's query. Now, here is where CRAG shines. Instead of simply using those documents to create a response, the system checks the generated content against the retrieved documents. If the model detects inaccuracies or if the information does not seem complete or reliable, the system performs another round of retrieval or adjusts the response before finalizing it. This ensures the low confidence answers are flagged and the model gets a chance to correct itself. Once the model has run through these correction steps, it generates a much more reliable and accurate response than if it had just used a single pass. The user then receives the final answers or response, which has been double-checked for accuracy and completeness. So why is this important? Well, in many critical areas like healthcare, law, or finance, giving a wrong or incomplete answer can have serious consequences. CRAG gives the model a second chance to correct itself and deliver a response that's as close to accurate as possible. It's like turning your AI into not just a search engine, but also an editor, making sure that the output is truly helpful. Let's dive into a powerful tool that can really help in making all of this even better, LangGraph. So what exactly is LangGraph? LangGraph acts like a blueprint for constructing the pipelines that bring everything together, retrieving data, processing it, and feeding it into our language models for even more powerful results. Essentially, LangGraph helps you build a modular system. If you are working on a complex AI task that needs multiple steps, retrieving documents, correcting errors, maybe even ranking the relevance of the information, LangGraph is perfect for setting up these pipelines in a clear, organized way. You can think of it like assembling a Lego set. where each block represents a key step in the retrieval and correction process. Now, here is where LangGraph really shines with CRAG. We have already talked about how CRAG corrects low confidence answers by retrieving more data or adjusting the response. Well, LangGraph can be used to structure and optimize the entire process. For example, you could use LangGraph to build the actual retrieval pipeline, making sure that when the AI detects a potential issue in its first response, it knows exactly where to go to get more relevant information. It also helps us to set up conditional workflows. Like if the AI thinks it's 70% confident in an answer, it might just retrieve one more document. But if it's only 40% confident, LangGraph can make sure the system fetches more data, rechecks, and maybe even involves multiple sources to get the best answer. Basically, LangGraph allows you to customize how and when your model retrieves information, runs corrections, and even grades the relevance of documents all in a scalable way. As for real-world applications, LangGraph can be a game changer in fields like legal tech, healthcare, or technical support, where accuracy and reliability are critical. For example, in a medical setting, LangGraph could help build a pipeline where the AI retrieves recent studies, checks for inconsistencies in its diagnosis, and corrects itself before suggesting a treatment plan. Or in legal tech, it could help by pulling relevant case law, ensuring that the system does not miss anything crucial before presenting a legal advice. LangGraph's flexibility makes it an incredible asset in any situation where AI needs to gather, assess, and correct large amounts of information before making decisions or providing answers. So in short, LangGraph is the engine that powers CRAG's intelligence, helping to guide and structure the whole process in a way that's both scalable and adaptable to a wide variety of real-world applications. Before the demo, I will briefly mention a new research on corrective retrieval-augmented generation, CRAG. CRAG improves the standard retrieval-augmented generation RAG by adding a corrective step, addressing potential retrieval inaccuracies. This paper introduces a retrieval evaluator that assesses the relevance of documents and triggers corrective actions when low confidence or inaccurate results are detected. Um, it ensures more robust generation by refining, retrieving additional data, or combining information sources. Um, Here is it. CRAG enhances AI's reliability, making it more adaptable to situations where accuracy is essential. All right, demo time. Just let me introduce the use case, which is a medical research assistance. A healthcare professional wants to find information about a rare condition and its treatment options. The information they need is scattered across various research papers, medical guidelines, and clinical trial reports. The challenge here is that a traditional RAG system might retrieve general information about the condition but could struggle with specific nuances of rare conditions or recent research findings. CRAG's component can refine the query to get more precise results and provide a more accurate answer. Okay, so here are some dummy data that I generated. So we have first some research papers, okay, and then we have medical guidelines, sorry, some protocols, some recent advances in the treatment of this rare condition and all this stuff. And we're going to ask the question, what are the latest advancements in treatment for rare condition X? Okay, So yes, let's go. But before that, let me just introduce you how or what our CRAG will look like. So here, as always, it starts with a query from the user. But here, before and unlike the 3, 2, 1. So here it starts with a query to user, and here, unlike the traditional RAG, we are going to take a decision. Or this query uh, uh, may be answered using our documents that we have, or it's off topic. Okay? If it's off topic, we end the conversation right here. Otherwise, if it's on topic, here we're going to retrieve some documents. Okay? And then we are going to start a loop. We are going to evaluate the documents. And here we're going to decide if the documents are not relevant, okay, we are going to improve our query, to optimize our query, and then get once again some documents that are more relevant. Okay, otherwise, we're going to generate, if the documents are relevant, we are going to generate a response and send it back to the user. Okay, let's start our demo, and now we're going to start by loading environment variables using load-env. And then I'll try to access these environment variables. Actually, I'm using Azure OpenAI, okay? So my environment variables are nothing more or less than the API version, the OpenAI endpoint, the API key. Also, I'm using Azure AI Search to create the search index and upload the documents, the dummy data that we just talked about. Okay, so the environment variables contains as well the search endpoint, the index name, and the search key. Then here in this section, I'm creating and uploading the documents. Okay, I'm creating the index, sorry. So first, I'm initializing, sorry, the search client and the index client. Then I'm defining the fields. Here I'm keeping it simple, so I'm creating 2 fields. The first one is the ID, and the second one is the content, which is a searchable field, so I can find the contents. Okay, so now here I'm initializing the index, and then I'm calling the function create index, so I can create the index in AI search. Okay, it's no more cognitive search, but now it's AI search. Then I'm taking all the data inside my folder data, which are these data, okay, and I'm loading them, and I'm uploading them into my index. Okay, and finally here I'm uploading it, and if everything went fine, I'm going to print the documents uploaded successfully. Okay, let's run this. Okay, here I have my documents. Right. So now in LangGraph, we are using what we call states. First, I'm creating a class called agent state, which contains the question, the grades, the evaluation of my documents, the response from the LLM, the documents themselves, and if I am or not on topic. Okay, so let me run this. And here I'm creating the LLM, which is once again the Azure OpenAI, okay, which uses GPT-4o, and I'm defining the retriever. The retriever is the place where I'm saving my data. Okay, so in my case is Azure AI Search. I'm defining it, and I'm telling that my content are inside content. Okay. Here I'm defining a function retrieve docs. This function will retrieve my documents from the retriever, which is AI search. Nice. And then here is for the evaluation of the the evaluation of the documents. Of the question. Sorry. Here we are checking whether the question is related to rare condition X or not. Okay. So let me just run it, and here we have the score. If it's yes or no, simply. Okay. And then I'm defining a function, question classifier, and I'm defining a system prompt because I'm using OpenAI to define if my question is about the rare condition X or not. So here we have a system prompt telling my model that I want only the questions about rare condition X. Otherwise, you say just no, it's not, it's off topic. I mean. Okay, so here I have the system prompt and then my question, and here I'm calling my LLM with my question, so it can tell me if I'm on topic or off topic, and I'm saving it into the states on topic. Okay, so here it's the decision, or I am on topic and I send it back to on topic, or I am off topic and I'm going to end. If it's off topic, so the response from the LLM, it will be, I cannot respond to that. Okay. Now it's time to evaluate the documents. I mean, it's a binary score indicating the document relevance to the user question. It indicates, or yes, they are relevant, or no, they are not relevant. Once again, this is a basic corrective RAG. I mean, you can improve it by adding some percentage like we talked before. Okay, so here I'm evaluating the document. And here I'm saying if this document is relevant, and once again I'm using the model, the OpenAI model, so I can evaluate the document. Here I'm generating the response. Okay, so if there is any relevant document, so I'm generating the answers. Otherwise, I'm sending it to optimize the query. And yeah, I'll let you, I mean, have a guess how we're going to optimize the query. Yes, once again, using the LLM. Okay, so here I am telling him that you are a rewriter. So if you receive any question, any input question, please improve it for better retrieval and find me a better question and improved one, improved version of the question. Um, and then I have another function, generate response. Okay, oh, I forgot to run everything, so I can go one by one here, here, and here. Okay, so now I generate the response, and okay, so now I'm defining my workflow. I mean, my nodes and the edges. So I define the node of the decision, the node of off topic, the node of retrieve documents, the node of optimizing the query, of generating the response, and to evaluate the document. Okay, and I'm adding edges. So the off topic is directly to end, and the retrieve documents is to document grader. And here the decision, if I'm on topic, I'm sending it to retrieve documents. If I'm off topic, I'm sending it to off topic. Same for grader for the evaluation, or I'm going to send it to generate response, or I'm going to send it to optimize the query. And here I have the optimize the query an edge with the retrieve docs. And don't worry, I'm going to show you everything with an image because like machine learning, this is something that I really like to say. It's visualize, visualize, and visualize. So yeah, and finally I'm generating the response and I'm sending it to the end edge, okay, to the end node, sorry. And the entry point is the decision. Okay, so I'm compiling my workflow. Nice. So now let me show you, I mean, the workflow. We start with decision. If we are on topic, we are retrieving the docs. We are evaluating the documents, optimizing the query, or generating the response. And if we are off topic, of course, it's the end. So now let me ask my LLM a question. Is it cold outside? It has nothing to do with the rare condition, right? So let me start this up. So as we see it started with a question classifier. So I'm here in the decision step. Am I on good topic? So and then like here in decision as well. And finally, it finds that it's off topic and it sends to the end and I cannot respond to that. Now let me rerun this, and this time I have a serious question about rare condition X. Okay, go ahead. So as well, question classifier, and then on good topic. Okay, so yes, I'm on topic, all right. And here to the document grader. So here it takes the other path, right? It was understandable question, so it generates the response, and then it generates from me the response, the latest now for rare condition include new treatments, drug G, entropy H, all this stuff. Yeah, here we are. In summary, CRAG represents a powerful evolution in information retrieval and generation, offering significant improvement over traditional methods. Its ability to correct and adapt in real time makes it an essential tool for managing complex and high stakes scenarios, ensuring that users receive the most accurate and relevant information available.